Okay, the second part of the lecture here is on statistical significance. We're going to explore what that term means just a little bit, if that's okay with you. So, as a weather person, I have a couple of simple examples. There'll be no homework for this, but this is the explanation of statistical significance. What if I asked you, I was trying to figure out if there is climate change or not, global warming, climate change, whatever you want to call it. And let's say that this particular summer, there is one day where the temperature exceeds 100 degrees. And I said, well, does this show evidence of climate change or not? Is this statistically significant? So, if there was one day, what would you probably say? Well, if there was one day of 100 degrees, you could say, you know what? That could happen due to chance. Because if you look back in the records of temperatures and climate, it's pretty common. Maybe 20% of the time, you could get one day in an average summer in Roanoke or in Stanton of 100 degrees. So if there was only one day, you'd say, you know what, there's about a 20% chance or 20% probability that that could happen due to chance. So if it's just one day, am I going to say that that result is due to chance, or is it due to climate change? You'd probably say, no, I'm going to say that's due to chance. So the big issue with statistical significance is trying to evaluate, is a result due to chance or is it due to some other variable, in this case, climate change. So if it was just one day, you'd probably say, you know what, one day in a summer, one day in a year, it's probably due to random chance. There's no climate change, and that's the way. You'd probably be right with that decision. You'd probably say, no, that's not statistically significant. It's just due to chance. That is the key question in statistical significance. You get a result from a study, and the idea is that result due to chance, or is it actually due to a variable? Do we have statistical significance? So if there was one day of 100 degrees, you'd probably say, well, that could happen due to chance 20% of the time, and you'd say that's not statistically significant. It's in fact due to chance, and you'd probably be correct. Let me give you another scenario, though. Let's say there are 30 straight days during the whole month of July. Every day, the thermometer gets to be over 100 degrees. And I said, is that result due to random chance, or is there a variable potentially causing that, such as climate change? And don't worry about the politics here. I'm not interested in that. This is just a good, hopefully, real-world example for you. But if there were 30 straight days, well, what a statistician would do is would go to the books and say, well, how often, just due to random chance, do you get 30 straight days of above 100 degrees? And if you look it up, the probability that that could happen due to chance is probably 1 in 1,000. Maybe in the last 1,000 years it's happened one time. So what you'd probably find is that in the last 100,000 years, maybe you've gotten 30 straight days of 100 degrees, maybe one time in the last 1,000 years. So the probability of this occurring due to chance is maybe 1 in 1,000. What a statistician would then do is say, well, is 1 in 1,000 a large probability or a small probability? And most of you would probably agree the probability of 1 in 1,000 is very, very low. And so what a statistician would then further do is would say, well, look, that probability is so low due to chance that I'll actually decide that that result is not due to chance. It's due to a variable causing that. And so now the conclusion might be this result, because it's 1 out of 1,000, is not due to chance. It's due to something else. And so you might conclude that some other variable is causing this, such as climate change, per se. So what we do in statistics is we try to decide if a result is due to chance or if a result is due to a variable. Is there a key number that helps us do that? The answer is yes. The key number, which determines significance or not, is 0.05. 0.05. If a result happens, such as day days over 300 degrees. If a result happens and the probability due to chance is less than 5 out of 100, if the probability due to chance is less than 5 out of 100, we actually decide that the result is not due to chance. It's due to something else. It's due to a variable, and we would say we have statistical significance. If a result could happen due to chance, like that first one, 20% of the time, that is more than 5% of the time, we decide that that result is not statistically significant and it is due to chance. The thinking is kind of reverse of what you would expect, but you got to think about the weather example. If you had one day of 100 degrees, that could happen due to chance 20% of the time, so that probability would be greater than 0.5, and you'd say that result is non-significant. If it was 30 straight days, the probability of having that due to chance is less than 5 out of 100. It's about 1 in 1,000. And you'd say, well, there must have been some other variable causing that, such as climate change. Thus, that result would be considered statistically significant. So I hope this makes sense to you. Let's try one other example. A number of years ago, there used to be something called the Psychic Friends Hotline. Do you guys remember that? Kind of interesting, the Psychic Friends Hotline. They could say they are psychic people. So let's just say that I'm working with a psychic and I have a deck of cards in front of me and the psychic says to me, I can tell you what the suit on the card is. And we start going through the deck, and the psychic is able to correctly identify 15 cards, the suit on the cards. Would you argue that that psychic is indeed a real psychic and has what telekinetic powers if they got 15 cards right? Well, think about it for a second. How many cards in a deck? There are 52 cards in a deck, and one of my favorite games growing up was to play 52 card pickup with my sister. You ever done that game before, 52 card pickup? You throw out the cards and then they have to pick them up. Ha ha ha. So they get 15 cards right out of the deck. So the question is, what is chance behavior there? If there are 52 cards, well, how many different suits are there? There are 4 different suits. So if somebody was just guessing due to chance, how many would they get right in a deck of 52? They would get 13 correct. So if somebody got 15 correct, would you say they're psychic or not? You would probably say no, because the results are too close to chance. Chance is 13, they got 15, that's pretty close. So if you think in terms of even chi-squares, that's very close, and that wouldn't be significant. So if somebody got 15 and you were to say, are they a psychic or not, you'd probably say, no, 15 couldn't happen. But let's take a second example. Let's say the psychic, or the person who says they're a psychic, comes in and has the deck of cards, and working with you, they get 48 of the cards correct. 48 out of 52. Would you say they're a psychic or no? Well, the way a statistician would think about that is they would say, well, 52 cards, what is chance performance? It's about 13. If somebody gets 50 or 48 cards correct, that is way above and beyond chance. So the probability that that could happen due to chance is very low. And so you'd probably say that result is statistically significant, and there would be some evidence of some psychic activity there, maybe, or cheating. So when we try to evaluate if something is statistically significant, the idea is we get the result, what we actually observed, 1 day, 30 days, 15 cards, 48 cards, and we try to figure out what is the probability that that event could have happened due to chance. If the probability that that event could happen due to chance is high, then we say that result is not statistically significant. If it could happen due to chance more than 5% of the time, we say that result was due to chance and we're not significant. If the result that we get could happen due to chance less than 5 out of 100 times, we say, well, that result is so unlikely that we'll make the decision that we have a statistically significant finding and that there is climate change, this person is a psychic, or people are statistically scared of math, and then we have a statistically significant conclusion. The 90 versus 10 was a classic example of that. The critical value was 3.84. You got a chi-obtained value of 64, and so the decision is that that really couldn't happen due to chance. We'd say it's statistically significant, and people are scared of statistics. So hopefully this makes sense to you. Wrapping this up, I just want to say you have a couple of homework problems to do. We got the chi-square problem in page 627. I've given you two other problems, just learning simple math things with sum of x, and feel free with those problems in chapter 1 and 2 to send me both the question and the answer so I can look at it and let you know if you got it right or wrong. I wouldn't necessarily post those on the discussion board with questions and analysis. Just send those to me as a draft and I can let you know if you did it right. If you feel comfortable with that, by Sunday night or Monday, just post those as an attached file with your notes as well. So hopefully this makes good sense, and have a good day. Bye-bye.